Okay, so firstly, what is the normal distribution? So the normal distribution is symmetrical. So it's when the distribution, like you've got all of your polygons, there's a symmetry. So if you drew like a line modelling that distribution, it would be symmetrical. The mean, the mode, and the median are all equal in a normal distribution, probably the same. Now, when you have this sort of symmetry, then the mean is in the middle. Now, the symbol for the mean is actually, looks like that. You also see it written as X bar. So in here, this is the mean. Now, if you move one standard deviation away from the mean, it would be the mean plus the standard deviation. This is the symbol for the standard deviation. Or if you go to the mean minus the standard deviation, then 68% of the scores will lie within this distance away from the mean. So one standard deviation away from the mean, 68% of the scores will lie. So this is your mean, and if you move one standard deviation away, so the mean plus the standard deviation, the mean minus the standard deviation, then 68% of the scores will lie within this range. Now, the Z-score will tell you how many standard deviations you are away from the mean. Deviations away from the mean. So what we're quite interested in is if we are is one standard deviation away, two standard deviations, and three. Now, two standard deviations away from the mean. If you were two standard deviations away from the mean, so here's the mean, and then you went two standard deviations above it and two standard deviations below it, then that would mean that that's 95% of the scores will lie within that range. So two standard deviations away is 95%. Three standard deviations away from the mean, above the mean, and three standard deviations below the mean, that's 99.7% of the scores will lie within the range, which, as you can notice, it's like the majority of the scores. So one standard deviation away from the mean is 68%, two would be 95%, will lie within that range, and three is 99.7%. Working out the standard deviations help you to compare data, which we'll do later. But to make it easier, what we do is we find the Z-score. So the Z-score will tell you how many standard deviations you are above and below the mean. So to calculate the Z-score is your actual score, which is X minus the mean over the standard deviation. So X is equal to the score, that symbol is equal to the mean, and this one is the standard deviation. Okay, so a test has a mean of 22 and a standard deviation of 3. So the mean's 22, the standard deviation is 3. To get the Z-score, it is X minus the mean on the standard deviation. So this will be 25 minus 22 on 3, which will be 3 on 3, which is 1. That means that this score is one standard deviation above the mean. 19, so if you did 19 minus 22 on 3, you end up with minus 3 on 3, which is minus 1, which means you are one standard deviation below the mean. You're looking at 31. 31 minus 22 is 9, and then divided by 3 is 3. So your 3 standard deviations above the mean, and 16 minus 22, which is minus 6 over 3 minus 2. So that means you'll be 2 standard deviations below the mean. So to find the z-score, you just do score minus mean over the standard deviation. And then, like, if you get a z-score, say, of minus 2, that's 2 standard deviations below the mean. So if you were looking at your diagram here, here's the mean. 2 standard deviations would be down here somewhere. So that means that you would be well kind of below the average, because we know 95% is there, and that's 2. A z-score where the mean is, let's say you had a score of 20 and your mean was 22 and your standard deviation, of 22, your standard deviation was 3, and when you do the z-score, so you have 22 minus 22 on 3, which is 0. That would be 0. 1 standard deviation is here, which is 68%. All the scores will lie from there to there. 2 standard deviations, which is here and here. That's 95% of the scores will lie there. And 3 standard deviations above and below the mean. That would be 99.7% of the scores will lie from there to there.